Hi, I am Noor, and today in this lesson 5 part 1 we're going to talk about sentiment classification with naive Bayes and logistic regression. So let's get started with this video. So to start today's lecture, these are the slides of today's video. So in this lecture we're gonna talk about sentiment classification with naive Bayes and logistic regression. So this is part 1 of lesson 5. These are the highlights of today's video. This is the objective of today's video, and these are the outlines. So first we're gonna discuss what a naive Bayes classifier is, then class priors and class occurrence events. Then we're gonna talk about class likelihood ratios, the log count ratio, and then Bayes theorem, which is really important. So let's get started with this lesson to know about these things and topics. So this is the notebook that we are gonna use for this lesson. So remember the last time we were looking at the problem of classifying the sentiment of movie reviews. So we're gonna do it with logistic regression in this notebook, which is naive Bayes. So we have two pronunciations for naive Bayes, which is naive Bayes and naive Bayes. But the more recommended one is naive Bayes. I've been using the naive one, but but I realized that it is most common to use naive. Okay, so and it's really important for you to understand how your data is set up and what we have like kind of methods and dictionaries are used in it. So the movie reviews object also contains .vocab property, even though it's not shown with dir method. This may be an error in the FastAI library, but we use .vocab attribute like this, and okay. So now we have another attribute which is stoi, which stands for string to integer. So movie reviews.vocab.stoi maps vocabulary tokens to their indices in vocab. So let me read this as well. So the vocab object is a kind of reversible dictionary that translates back and forth between tokens and integer representation. So it has two methods of particular interest, stoi and itos, which stands for string to index and index, I said integer. Okay, so string to index and index to string. So here we are using two attributes in total, which are the first one is vocab and the second one is stoi, string to index. So this is how we do. Then I have some interesting queries that I would recommend you to see after this lesson here about stoi and itos. Okay, so the next thing and very important thing is what is a naive Bayes classifier. So naive Bayes classifier is an algorithm that actually encodes this simple reasoning process mathematically. So it is based on two important pieces of information that we can learn from the training set, which are class priors and the token likelihoods. Okay, so the class priors are the probabilities that a randomly chosen review will be positive or negative. So this will determine the reviews from movie reviews, like which review is negative and which one is positive. And the token likelihoods are like how likely is that a given token would appear in a positive or negative review. So first thing that I want to clear is like we can't take a whole review and just review it as a positive or negative while coding. So what we have to do is to actually process them and see which one is positive and which one is negative. We create tokens for computer to understand, and the token likelihoods will see which token would appear in a positive and negative review. So as I explained, like we can take a whole sentence and give it to computer for to check it, like if it is negative or positive. So the thing we're gonna do is we create tokens, and those tokens will help computer, like in a positive movie review we can see, maybe we can see good and nice appearing most of the time, so we will compare it with the next review, and then we'll continue it. So it turns out that that this is all the information we need to build a model of capable of predicting fairly accurately how any given review will be classified given its text. Meanwhile, in this section we will focus on how to compute necessary information from training dataset, and specifically the prior probabilities for reviews of each class, and the class occurrence counts and class likelihood ratios for each token in the vocabulary. So let's have a look on class priors. So what are class priors actually? So class priors refer to the likelihood or probability of each category or class occurring in a dataset before considering any specific features or attributes of the data. Okay. So for this, the equations and the formulas here, I will explain it in a short way. So these equations actually calculate the in this equation I explained that these equations calculate class priors from training data. P is the probability. Here you can see P is the probability of a positive class obtained by dividing positive reviews, which are n plus, you can see here n plus, and by total reviews, and the total reviews are n, so we are dividing it. Okay, so the q is the probability of negative class, which is equals to 1 minus p. Here you can see. So these priors actually reflect initial class probabilities before considering specific features. The next thing is class occurrence counts. So the class occurrence counts, what actually does is, like it is a number of class occurrence counts are the number of instances belonging to each category in a dataset, which is essential for understanding class distribution and influencing class priors and model training. So then we're gonna explore the data with class occurrence counts. Okay, so you can see it after the lesson. Okay, the next thing was maybe, and I have some really interesting exercises that you can practice to get better at it. So the next thing is class likelihood ratios. So class likelihood ratios actually quantify, I will actually briefly explain this equation. Okay, so class likelihoods actually quantify how likely a token is to appear in one compared to another, where C plus T and C minus T are actually token counts in positive and negative classes. So n plus and n minus are the total token counts in these classes, determining the tokens relevance to each class. You can see here. Okay. So the next thing is the log count ratio. So what actually a log count ratio is? The log count ratio RT measures a token's tendency to appear in a positive or negative reviews by comparing to maybe their conditional likelihoods. So RT, which is ratio, greater than 0 indicates like the token's preference for positive reviews, and less than 0 for negative, and ratio equals to 0 for equal likelihood. Here you can see the things I mentioned here as we observed that. So the next thing is we are building a naive Bayes classifier with IMDb movie reviews. So from the occurrence count arrays, we can compute the class likelihoods and log count ratios, as I explained, of all the tokens in the vocabulary. So first we will compute the class likelihoods. You can see the code later because this is really simple. So then we will compute the log count ratios. After that, what we're gonna do is we have a simple exercise that you can see. Then we will get the indices of the tokens with the highest and lowest count ratios. See here, we are getting those indices. Then we're gonna compute some positive words and so on. So let's go. Okay. So the next thing is Bayes theorem, which is really important. So what is Bayes theorem and what does it have to say about IMDb movie reviews? Like, what is the connection between them? So I will explain this in short. So Bayes theorem relates to the probability of two events occurring together with their conditional probabilities. So in the context of IMDb movie reviews, it helps us to like predict the likelihood of a review being positive or negative based on the words it contains by comparing the probability of the words given the sentiment and the overall sentiment probability. So now it's again the implementation of the movie review classifier. You can see here. So you guys can check it out and let me just overview the steps of it. So first what we will do is okay, let me see first. Okay, so yeah, this is the actual thing. Okay, so first we will download the data. Then what we will do is pre-process the data, like remove all the noises that we don't need, remove the unnecessary data. So pre-processing is actually about removing all the unwanted stuff to gain the valuable information to proceed in our work with the data set. So we will remove all the things, noises from the data, and then we will create document term matrices for training and validation sets. After that, we will save the data, and that's all for today. I will see you in the next lesson, in the next part of this lesson. So till then, take care. Bye bye. Keep learning and keep exploring.